Hey Miss Brown's class, today we are working with finding area of composite shapes. So what that means is I'm going to figure out what the area of this whole weird shape is, even though it's not what we've already learned. We've talked about rectangles, squares, parallelograms, triangles. We've talked about all sorts of polygons. But now today we're getting into something new looking. So in order to make it less scary, what I'm going to do is I'm going to divide this up so it's only rectangles. So you can choose, do you want to do two vertical lines here? So we have rectangle, rectangle, rectangle. Or do you want to make two little horizontal lines going here? So you have a tiny rectangle here, a large one up top, and a small one down here. It's your choice. Either way, you'll still get the same answers. So I'm going to go ahead and make two vertical lines. For this lesson, I highly suggest having out a sheet of paper so that way you can go ahead and you can draw the lines on your paper and you can label everything. Otherwise, keeping all the numbers in your head is going to get very confusing and you do not simply just multiply everything you see. That's not going to work. Okay, so what I would do here is I want to find what's the base times the height. Now this 2 here only represents this short side. So the way that I would figure out how much this long side is worth is by looking at the opposite side over here. So if this side is 7, then this side should also be 7. Okay, so 7 times 6 is 42 feet squared. And this is the same rectangle on the right side. It will not always be symmetrical, but in this drawing it is. So this one's also 42 feet squared. Now, this rectangle is missing literally everything that I need. So what I could do in order to figure out the height and width of this rectangle is, if the whole top is 15 feet, do 15 minus this 6 and minus that 6. And that'll give me what's left here. So 6 and 6 is 12. So 12 plus what equals 15? That should be 3 feet here, as far as how wide it is. Now the height I figure out by looking, okay, if this whole shape was 7 feet tall here, and I cut off 2 feet here, then 7 minus 2 should be equal to 5 feet tall. So now I'm saying, what's 3 feet times 5 feet? This area should equal 15, why does that not work? 15 feet squared. Now what I do with all of my partial areas is I add them up. You're welcome to use a calculator here or do it on pencil and paper. So 42 plus 42 should give you 84. And then plus another 15, that should give you 99 feet squared. Now remember how I said you can do it by making two horizontal lines? You should still get 99 feet squared, okay? But aside from adding up 3 small rectangles, I'm going to show you another strategy that you could use. Same problem, let's see if we get the same answer. I sure hope so. Okay, so another strategy that some people like to use is that they imagine this whole thing as being one gigantic rectangle that closes here. If this is all one giant rectangle, what I'm basically going to do is I'm going to subtract this smaller rectangle at the end. So I would say to myself, 15 times 7 is what? 35, carry the 3, 10. So your total area should be 105, right? But now I have to subtract this purple part that I didn't want. So from the way that we just did the problem before, we knew that 15 feet minus 6 is 9. 9 feet minus this 6 is 3. So 3 times 2 is 6. So 105 minus 6 feet should be 99 feet squared. Okay, so whether you add up parts of the shape or you subtract a piece of the shape, either way you should still get the same answer. Okay? Now we're going to switch it over to something where we have to use the area of a triangle formula. All right. Just draw a big old rectangle here. Oops, that didn't connect. And a triangle. All right, so let's pretend that your teacher can draw. Now what we want to do, well, if this came with labels, let's say this is 12 yards, this is 2 yards, 5 yards, and then you need to know the height of this triangle. Let's say the height of this triangle is 4 yards. Okay. The rest of this problem we can figure out on our own. So first of all, in order to find the triangle, that's equal to 1/2 base times height. Now, the base of this triangle, oh, I need one more piece of information, I'm sorry. Let's call that 9 yards. The base of this triangle, the way we would find that width is by doing what's this whole length minus that length, because that'll give us what this spacing is here. And this spacing for the rectangle should stay consistent the whole time. And since the rectangle shares a side of the triangle, they should go together. So what's 12 yards minus 9 yards? Okay, so I'm going to label a new information that we're figuring out in a different color. So then that one should be 3 yards for the width. So since I already found the width of that vertical rectangle, I'll leave it like that. Now, as for this horizontal rectangle here, I see 9, 2, and 12. This is where you have to get selective. Do not multiply all 3 numbers, please. Okay, so you're thinking, is the width of this rectangle this whole distance or that distance? Hopefully you're thinking the top, which is 9 yards. So you're saying 9 times 2 is 18 yards. Okay. This one over here, it was 3 yards across that we found out from subtraction. 3 yards times 5 yards, that's 15 yards squared. Now for the triangle part, I leave 1/2 always. Base is 3, height is 4. Let's do what's inside of parentheses first. 3 times 4 is 12. So what's 1/2 of 12? That means your triangle should be equal to 6 feet squared, or 6 yards, sorry. 6 yards squared. So now what I do is I add up my 3 pieces. So I have 15 plus 6 is 21. 21 plus 18 should give me 39 yards squared. Okay? Once again, on this problem, if you wanted to extend your line this way and make a small rectangle here and a longer rectangle, that's fine. But you do need to be able to see that this has a triangle as well as the rectangular formulas too. All right, I'll see you next time.